In the last video, we have seen that in case of isobaric process, heat absorbed delta Q is equal to delta U plus delta W. Isobaric process means it is a process where pressure remains constant. Delta Q is equal to delta U plus delta W is nothing but P into delta V. So, pressure remains constant, therefore, this equation remains the same. There is no change in this equation. Now, let us see how much work is done or what is the expression for work done in case of isobaric process. So, we know that delta W is equal to P into delta V. So, pressure is constant. So, you should not write delta P. If there is change in pressure, then only you have to write delta P, because always delta means there is change. So, delta W is equal to P into delta V means change in volume. How to calculate the change in volume? Final volume minus initial volume will give you the change in volume. If V2 is the final volume of the system and V1 is the initial volume of the system, then V2 minus V1 is nothing but delta V. So, this is the expression for work done, or we know that in case of an ideal gas, PV is equal to mu RT. This is the ideal gas equation. PV is equal to mu RT is the ideal gas equation. Here pressure is constant, volume changes. So, V2 minus V1 is equal to, mu is always constant. Mu means number of moles present in a gas. So, mu R is also constant. T, temperature changes. So, when volume is V2, temperature is T2. When volume is V1, temperature is T1. So, P into V2 minus V1 is nothing but mu R T2 minus T1. So, here I write delta W is equal to P into V2 minus V1 is nothing but mu R T2 minus T1. So, this is the expression for work done in case of isobaric process. Delta Q is the heat energy absorbed by the system. So, part of the heat energy is used to increase the internal energy or to increase the temperature, and part of the heat energy is used to move the piston or used to do work. So, the expression for work done delta W is equal to mu R T2 minus T1. So, these are the four thermodynamic processes. First one is isothermal process, second one is adiabatic process, third one is isochoric process, and the fourth one is isobaric process. So, in thermodynamics, we use some sign conventions for heat and work. What are the sign conventions we use in thermodynamics? Let us see the sign conventions for heat and work. First one, if heat energy is absorbed by the system, then Q is positive. If heat energy is absorbed by the system, then Q is positive. If heat energy is released to the surrounding, if heat energy is released to the surrounding, then heat, Q is negative. Second point, in terms of work, if work is done by the gas, that is in case of expansion, if work is done by the gas, then W is positive. If work is done on the system, then W or work is negative. So, these are the sign conventions used for heat and work. While solving the problems, you should know about the sign convention. This is very, very important while solving the problem. So, if heat energy is absorbed by the system, then Q is taken as positive. If heat energy is released to the surrounding, then Q is negative. Similarly, if work is done by the gas, then W is positive. If work is done on the gas or on the system, then W is negative. Next one is cyclic process. Cyclic process. What do you mean by cyclic process? Cyclic process means if the process or if the system undergoes series of changes and if it returns to the initial state after the changes, if it returns to the initial state, then we call the process as the cyclic process. That means, consider one example. There is a system filled with gas and there is piston. During expansion, work is done by the gas. When this happens, this piston moves in the upward direction, system expands. When there is compression, work is done on the system, so piston moves in the downward direction, so volume decreases. If this gas is allowed to expand isothermally, I will draw pressure versus volume graph here. In case of isothermal expansion, what do you mean by isothermal expansion? Isothermal expansion means temperature should be constant. Throughout the process, if temperature of the system is constant, pressure and volume varies. If temperature remains constant, then we call that as isothermal process. So, in case of isothermal expansion, during expansion, volume increases, pressure decreases. So, pressure decreases, but volume increases. So, this is the isothermal curve. So, state A, this is state B. At A, pressure of the gas is P1 and its volume is V1. P1 and V1 are the initial pressure and volume of the system, volume of the gas. When it expands isothermally, so this is isothermal expansion, pressure decreases, volume increases, but the temperature of the system remains constant. So, this is the initial state. Here pressure is P1, volume is V1. When it reaches this state, pressure becomes P2, volume becomes V2. So, this is the state B where pressure is P2 and volume is V2. Now, the system is made to undergo adiabatic expansion. Adiabatic expansion. What do you mean by adiabatic process? Adiabatic process means no heat flows between system and the surroundings. So, Q is constant, delta Q is equal to 0. So, from P to V2, so this is the initial state of adiabatic expansion and this is the final state. Adiabatic expansion means pressure, volume, temperature. So, pressure varies from P2 to P3, volume varies from V2 to V3. So, how to draw PV graph for adiabatic expansion? Adiabatic process means it is a sudden process or it is a quick process. So, adiabatic expansion, there is sudden increase in volume. So, sudden change in pressure or the pressure decreases suddenly, quickly. So, this is the graph. So, this is the initial state P2 V2. This is the next state. Here the pressure becomes P3 and volume is V3. Now, isothermal expansion is over, adiabatic expansion is over. Now, the system is made to undergo isothermal compression. From here to here, the system undergoes compression. Compression means work is done on the system. So, from pressure changes from P3 to P2, volume changes from V3 to V2. Compression is isothermal compression. So, isothermal compression means it is a slow process. Compression means there is decrease in the volume and increase in the pressure. So, this is the graph. Volume decreases but pressure increases slowly. So, this is the case. It is not necessary that the pressure must be is equal to P2 V2. The pressure changes pressure may vary from P3 to P4, volume varies from V3 to V4. So, point D, pressure is P4, volume is V4, but the temperature is same. Now, the system is compressed adiabatically from here to here. Adiabatic compression means it is nothing but sudden compression. So, there is sudden decrease in the volume and increase in the pressure. So, this is the graph. Finally, the system comes to its initial state. So, this is the initial state. After series of changes, it returned to the initial state. So, initial and the final states are one and the same. So, this process is called as cyclic process. It is a process where the system undergoes series of changes, but finally returns to the initial state. So, this is called cyclic process. It is not necessary that the cyclic process should have 4 arms, no. So, this is also a cyclic process. Here we have 3 processes. It involves 3 processes. This is the initial point. Finally, the system returns to its initial point. The process is cyclic one. If it contains 2 arms, it is also fine. This process is also called as cyclic process because the initial and the final points coincide. So, in general, cyclic process means it is a process where the system undergoes series of changes and after those changes it returns to the initial state. So, what is the definition? How to write the definition for cyclic process? It is a process in which system is made to undergo a series of changes and the system finally returns to its initial state. This is called as cyclic process. Heat engine. So, almost all the engines use this process, that is cyclic process. What do you mean by heat engine? Heat engine is a device by which the system is made to undergo for a cyclic process and it converts heat energy into mechanical energy. Here the process involved is cyclic process. The process involved is cyclic process and it is a device or it is a machine. Heat engine is nothing but a device or it is a machine which converts heat energy into mechanical energy. Heat engine is a device which converts heat energy into work or heat energy into mechanical energy. So, how to write the statement? It is a thermodynamic device heat engine is a thermodynamic device by which the system is made to undergo for a cyclic process and which converts heat energy into work or heat energy into mechanical energy. So, this is the definition of heat engine. Basically, it is a device or it is a machine which converts heat energy into mechanical energy. Now, let us see how this heat engine works. What are the essential parts involved in case of heat engine? So, heat engine, for example, in case of a car, when petrol burns in our engine, lot of heat energy is produced, therefore, temperature also raises. There is increase in temperature, there is lot of heat energy. This heat energy is used to move the wheels of the car. Heat engine means it contains cylinder, it contains piston. So, together we call that as heat engine. So, when petrol or the diesel burns, heat energy is produced, that heat energy is used to move the wheels of the car. In case of steam engine, steam is used to move the wheels of the wheels of the train. So, what are the essential parts in heat engine? Here we have three essential parts. First one is hot reservoir. Hot reservoir or reservoir at higher temperature. or it is also called as source. First one is hot reservoir or reservoir at higher temperature or the source. Let us see what is the schematic diagram of heat engine. So, here we have the hot reservoir whose temperature is T1. So, this is the schematic diagram of heat engine. Here we have the working substance. Working substance, and then we have the cold reservoir. Which is at some lower temperature T2. So, these are the three essential parts in case of heat engine. We have hot reservoir, working substance and the cold reservoir. Hot reservoir or the source, it is also called as source. Cold reservoir is also called as sink. Temperature of the sink is always T2, temperature of the source is always T1. How this works? Hot reservoir, temperature of the hot reservoir is T1. Working substance takes heat energy from the hot reservoir. Hot reservoir means when petrol burns, again when petrol burns, a lot of heat energy is produced, temperature also raises. This heat energy, let Q1 be the amount of heat energy produced in burning petrol or diesel, Q1. So, this heat energy is absorbed by the working substance. Q1 is the amount of heat energy received from the working substance. So, this is Q1. But here temperature of the hot reservoir always remains constant. Whatever amount of heat energy you want to take from the hot reservoir you can take, but the temperature of the hot reservoir will not decrease. It always remains the same or it always remains constant, because when petrol burns, at first some amount of petrol is burned and that a lot of heat energy is produced. That heat energy is used to move the piston which moves wheels of the vehicle. When lot of heat energy is produced in burning petrol or diesel, that heat energy is taken from the working substance, taken by the working substance. When it takes heat energy, again some amount of petrol is burnt, again temperature reaches T1, heat energy is absorbed by the working substance. When this process happens, again some more amount of petrol is burnt, again temperature reaches T1 and Q1 amount of heat energy is absorbed by the working substance. So, this process continues. Therefore, always temperature remains T1 only. Temperature will not decrease, always its temperature is T1. That is, for example, ocean. You can take whatever amount of water you want to take, you can take from the ocean, but the water level will not go down. Similarly, in case of hot reservoir, you can take how much heat energy you want to take, you can take that much amount of heat energy from the hot reservoir, but its temperature always remains at T1. If its initial temperature is 400 degrees Celsius, then its temperature will be 400 degrees Celsius only. So, this is the speciality of this hot reservoir. This hot reservoir is also called as source and its temperature is remains always remains constant and its temperature is T1. So, when this heat energy is taken by the working substance, what is the working substance here? Second part is working substance. When the fuel burns, gases are produced. These gases carry heat energy from the hot reservoir. Gas is nothing but the working substance here. So, the gas carry heat energy from the hot reservoir. When they absorb heat energy from the hot reservoir, they expand, right? Temperature increases, temperature changes, gas expands. Whenever there is expansion, piston moves up. When it moves up, there is expansion, piston moves up. This piston is connected to the wheels of the vehicle. So, wheels of the vehicle move. That is nothing but work done. So, work is done. Work is done by the substance. So, work done, W. So, here gas is the working substance. When it absorbs Q1 amount of heat energy from the hot reservoir, it expands. When it expands, piston moves up and this piston is connected to the wheels of the vehicle. Therefore, wheels of the vehicle move. That is nothing but mechanical energy or work done. We say work is done. Third part is cold reservoir. Cold reservoir or sink or the reservoir at lower temperature. Reservoir at lower temperature T2. At lower temperature T2. Here we have the temperature T2. Q1 is the amount of heat energy absorbed from the hot reservoir. So, all the heat energy absorbed is not used to do work. So, some of the heat energy is used to do work or to move the piston and some of the heat energy is rejected to the sink. Sink is always at lower temperature T2. Sink or the cold reservoir. What is this cold reservoir? How it works? Here always the excess heat energy is some part of the heat energy absorbed is used to do work and the excess heat energy is used or excess heat energy is rejected to the sink or it is rejected to the cold reservoir. Here also this cold reservoir or the sink has the same property as that of the source. How much heat energy you want to add, you can add, but its temperature always remains constant. Its temperature will not increase. Temperature always remains the T2. Similar in case of ocean, if you want to add some water to the ocean, you can add, but the water level will not increase. So, here also cold reservoir, temperature of the cold reservoir always remains the same, its temperature will not increase. So, this special property, this is the special property this cold reservoir has. So, T2 is the temperature of the cold reservoir. T2 is always less than T1. T2 is always less than T1. We all know that heat energy flows from a region where the temperature is high to a region where the temperature is low. So, heat energy flows from hot reservoir to the cold reservoir because the hot reservoir is at higher temperature and the cold reservoir is at lower temperature. So, Q1 is the amount of heat energy absorbed from the hot reservoir, Q2 is the amount of heat energy released to the cold reservoir, W is the work done. So, this is a schematic diagram of heat engine. Now, let us see what is the expression for work done. How to calculate this work done? W is equal to work done, W is nothing but Q1 minus Q2. Q1 is the amount of heat energy absorbed by the working substance, Q2 is the amount of heat energy released by the working substance. So, difference between these two, Q1 minus Q2 is nothing but work done. So, W is equal to Q1 minus Q2. W is equal to Q1 minus Q2. So, this much work is done in case of heat engine. Now, how to calculate or how to know the quality of this heat engine? We can measure this using efficiency. In terms of efficiency, we can measure the quality of the heat engine. What is this efficiency? Efficiency is denoted by the symbol eta. This is efficiency. Efficiency is nothing but eta, symbol of efficiency. Efficiency is equal to output. How to calculate the efficiency? Output divided by input. Output by input, the ratio of output and the input is nothing but the efficiency. Always the output must be high, input must be low, then only efficiency is high. Because efficiency and the input, they are inversely proportional to each other. If input is more, then the efficiency is less. In this example, in case of heat engine, output is nothing but the work. Therefore, the efficiency eta is equal to output is nothing but work or work done divided by input. What is input here? Input is nothing but the amount of heat energy Q1. So, input is Q1, work done divided by Q1 is equal to work done is nothing but Q1 minus Q2, Q1 minus Q2 divided by Q1. So, this is the expression for efficiency of heat engine. This is the expression for efficiency of heat engine. Eta is equal to Q1 minus Q2 divided by Q1, or eta is equal to Q1 minus Q2 divided by Q1, or eta is equal to efficiency eta is equal to Q1 by Q1 1 minus Q2 by Q1. Eta is equal to 1 minus Q2 by Q1. This is the expression for efficiency eta. Here Q2 is the amount of heat energy rejected to the sink, and Q1 is the amount of heat energy received from the source. If Q2 is equal to 0, if Q2 is equal to 0, that means Q2 0, 0 by something, 0, efficiency eta is equal to 1 minus 0, which is equal to 1. This is the maximum efficiency. Eta is equal to 1, or the efficiency of the heat engine is maximum when Q2 is equal to 0. Q2 is 0 means all the heat energy absorbed by the working substance is used to do work. All the heat energy absorbed is used to move the piston in which moves wheels of the vehicle. No heat energy is rejected to the sink, that is Q2 is equal to 0. If Q2 is equal to 0, that means we know that heat energy flows from T1 to T2, Q1 to Q2. If Q2 is equal to 0, that means the flow of heat energy stops. If the flow stops, then no work can be done. This is not possible to have Q2 is equal to 0. This is only possible in case of ideal systems. In practical, it is not possible to have Q2 is equal to 0. Always some amount of heat energy is rejected to the sink, therefore, Q2 can never be equal to 0. If Q2 is not equal to 0, then efficiency eta is equal to 1 minus something. Efficiency eta is less than 1. Always efficiency eta is less than 1. It is not possible to have 100% efficiency. So, efficiency cannot be is equal to 1, or it is not possible to have 100% efficiency, because always some amount of heat energy is rejected to the sink. Q2 is not equal to 0. This is in case of heat engine.